Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Chapter 7, Introduction to Probability, and Section 7.1 is about probability and odds. We start by probability and sample spaces. When we toss a coin, tossing a coin is called a probability experiment. When we toss a coin, we get either head or tail. If the coin is fair, so the two possible outcomes, head or tail, have an equal chance of occurring. And we say that the outcomes in this case are equally likely. Now, if the experiment have a total of n equally likely outcomes, like for example tossing a coin, there are two equally likely outcomes. And k of these outcomes would be considered successes. For example, if success when tossing a coin is getting a head, so number of getting success would be 1 head, and the total number of outcomes is 2. So the probability of achieving success is k over n. So probability of head when we toss a coin, probability of head is 1 over 2. And probability of tail is also 1 over 2 if you consider T as success. So if an event E and event is set or subset of the sample space. If an event E happens in k ways, so this is the number of possible outcomes in E, or let us say the number of successes. And the total number of outcomes of equally likely outcomes is n. So the number of possible outcomes is in the sample space. So the probability of the event E would be k, number of elements or successes in E, over number of elements in the sample space. For example, if we draw a ball from a bag containing 4 white balls. So I have a bag and there are 4 white balls and 6 black balls. Now, what is the probability of getting a white ball? So white ball is success in this case. So according to this formula, what is the number of successes? What is the number of white balls? So the number of white balls, I can say probability of white, where the event is white ball. How many white balls are there? 4. And the number of possible outcomes in general, how many balls? There are 10 balls in general. Notice here that we are drawing a ball, one ball. So we have a bag that contains 10 balls, 6 of them are black and 4 are white. So if we draw one ball, select a ball from the bag, a possible outcome would be white and another outcome would be black. So in fact, there are two outcomes, either white or black. What is the probability of white in this case? 4 over 10. What is the probability of black getting a black ball? It is 6 over 10. Notice that these two outcomes, B and white, are not equally likely because the probability here is 4 over 10 and the probability here is 6 over 10. It's not like tossing a coin. Not getting a white ball, not getting white means getting a black. So not getting white would be black, and probability of black is 6 over 10. So the answer of part C is also 6 over 10. Now what is the sample space? It is set, it's a set of all possible outcomes of the experiment. So when we toss a coin, the sample space would consist of the set of head and tail. These are the two possible outcomes. In this exercise, when we draw a ball, in this example, drawing a ball from this bag and see the color of this ball, we have two outcomes, either white or black. For the experiment of randomly drawing, this is another experiment. Let us consider an experiment. What is the experiment? Draw one card, a number card, from a box of cards numbered from 1 to 12. So we have 12 cards in the box numbered from 1 to 12. Draw a card and notice the number on that card. This is the experiment. What is the sample space of this experiment? Well, if you notice the number on the card, there are 12 cards, so there are numbers from 1 up to 12. So this is the sample space in this case. So a possible outcome would be what? Would be 3, would be 4. Selecting a card, look to the number, you will see a number from 1 to 12. All outcomes in a set is called sample space. Each element of the sample space, 1 to 12 here, is called the sample point. It's a point. What is an event? Event is a subset of the sample space. So for example, we can talk about the event of obtaining an even number or an odd number. Okay, it would be a subset of the sample space. Now each sample point has a probability. I can ask you, what is the probability of obtaining 1, obtaining 2? We call it probability weight. Okay, the sum of the weights should be equal to 1. So probability of 1 plus probability of 2 plus probability of 12 should be equal to 1. So the probability of S sample space is always 1. Probability of an event, how to find probability of the event E? You add the weights inside this event, the weights of the points or the elements inside this event. So for example, let us talk about this event. What is the event? Drawing an even number. Here, the same experiment. So what are the even numbers? 2, 4, 6, 8, and 1, 3, 5, 7 are the odd numbers. So the even numbers between 1 and 12 are 2, 4, 6, 8, 10, 12. Now, if I want to find the probability of E, it would be the probability of 2 plus probability of 4 plus probability of 6 plus probability of 12, 8, 10, 12. You add all of the probabilities. Now, if this experiment is equally likely and the possibility of selecting one card is equal to all the other cards, then we have 12 possibilities. So the probability of selecting any number is 1 over 12. So this would be the probability weight in this case, because it is equally likely experiment. So the probability of E would be 1 over 12. This is the probability of 2 plus 1 over 12, probability of 4, probability of 6, probability of 8, probability of 10, probability of 12. If you add, you get 6 over 12, or just half. Or you add the number of elements in E. How many elements in E? We denote the number of elements in E by n of E. So what is n of E? It means number of elements. So number of elements in the sample space is denoted by n of S. So if we assume that the number of elements in the sample space is n and the number of elements in the event E is k, then the probability of E would be k over n. All right. So here, for example, the probability of E would be the number of elements in E6 over the number of elements in the sample space, which is 12. So in this example, number of elements in E is 6 and number of elements in S is 12, and the probability or the experiment has to be equally likely. Okay, if the experiment is not, or the outcomes are not equally likely, then you cannot use this rule. Okay, this rule is only used in equally likely. Okay, if it is not equally likely, you obtain the probability of an event by adding the sum of the weights, and in that case the sum of the weights will not be equal. All right, but if it is equally likely, then you just divide the number of elements in E by the number of elements in S. Let us see this example. If a number is to be selected at random, so we are selecting what? One number at random from the integers from 1 to 12. So if I ask you what is the sample space in this case, or what is a single outcome, or what is the experiment first, you need to understand the experiment first. I'll tell you that the experiment is selecting a number from 1 to 12. A possible outcomes 11. A possible outcome 11, 10, 9. So put all the outcomes in a set. This is called the sample space. Now, probability of selecting a number would be the same for all the numbers. So probability of each number would be 1 over 12, the probability weight of each element. Now, what is the probability that this number is divisible by 3? So divisible by 3, this is an event E. So let me call it E. What are the numbers inside this event? I need to find all the numbers from 1 to 12 that are divisible by 3. So 3 is divisible by 3, 6, 9, and 12. All of these numbers are divisible by 3. So the probability of E, the question, what is the probability of each of these events? Probability of E would be what? How many elements in E? 4. How many elements in the sample space? 12. So this is the answer of part E. Part B, even and divisible by 3. Let me call this this event G, for example. I need the number to be even and at the same time divisible by 3. These are the numbers divisible by 3. What are the even numbers among them? 6 and 12. So these are the elements in G, even and divisible by 3. What would be the probability of G equally likely, all the outcomes are equally likely. So probability of G would be 2 because there are two numbers in G over the total number in S, over the number of elements in S. In C, the event, let me call it H, is even or divisible by 3. So divisible by 3 are there, all of them, because an element here in H could be divisible by 3 or even. And all the even elements or all the even numbers from 1 to 12 should be here too. So 2 should be here, 4 should be here, 6, but it is already there. So 8, 10, 12, but 10 is already there. So these are the numbers inside H. Each one of them is even, or one property is enough. It is even or divisible by 3. So what is the probability of H? How many elements in each? 2, 4, 6, 8. So the probability is 8 over 12 because the experiment is equally likely. Checkpoint if a coin is drawn. So how many coins? One coin. We are selecting one coin from a box containing 4 gold, 10 silver, 16 copper coins. So how many coins in general? 10 plus 4, 14 plus 16, 30. So there are 30 coins. So this is the number of elements in the sample space. There are 30 coins. And we are selecting a coin, one coin from these 30 coins. So this is the experiment. And the number of the sample space is 30. We have 30 elements. Okay. Now uh, all have the same size. Okay. All of these coins have the same size. What is the probability of getting a gold coin? Well, the probability of getting a gold coin, we can say it's probability of this coin being a gold. Well, how many gold coins are there? There are 4 gold coins. And how many in 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 general, in total, there are 30 coins. So probability of gold is 4 over 30. Getting a copper coin, so probability of C, let me call it C, copper coin. How many copper coins are there? 16, and the total number of coins is 30. Okay, so the probability is 16 over 30. Not getting a copper coin. Not getting a copper coin means we will get either silver or gold. How many silver and gold are there? 14. So the probability of not copper is 14 over 30. So if E, if the event E is certain to occur, certain, this means it has all the elements of the sample space. So when we say an event is certain to occur, we are talking about S, in fact. What is the probability of S? Probability of S is 1. So if I ask you, for example, here, selecting a coin, what's the probability of obtaining a gold or silver or copper coin? I'm asking about all of them. So the probability is 30 over 30, and it is 1. While if event E is impossible, it can't be, there is no event like this. So the probability of E would be 0. For example, selecting a coin from here, from these 30 coins, what is the probability of obtaining a pen? Okay, there is no pens, they are coins. So the probability of obtaining a pen would be 0. So such impossible events, their probability is 0. All other events, okay, E, not S, if it is not S and not phi, the impossible events, its probability would be always between 0 and 1. If it is S, probability is 1. If it is phi, probability of 0. Otherwise, the probability of event E would be between 0 and 1. Another example, suppose a fair coin is tossed 3 times. Now, when we toss a fair coin 3 times, well, the first coin, there is a possibility that the outcome is head or tail. This is the first coin. Now, what about the second coin? If the first coin is head, the second coin could be also head or tail. If the first coin is tail, the second coin could be also head or tail. Now I have the first and the second. What about the third coin? Also, I have a new possibility. So if I ask you, what is the experiment? What is the experiment here? The experiment, tossing a fair coin 3 times. Give me an outcome. The question, construct an equiprobable sample space. Give me an outcome of this experiment. what is an outcome? Is H an outcome? No, because I'm tossing the coin 3 times. So after 3 times, I cannot tell you, I cannot say the outcome is H. You have to tell me 3 things because I'm tossing the coin 3 times. So an outcome could be H, H, H. If I ask you, toss a coin 3 times, what is your answer? What is your outcome? What did you get? You can say H, H, T, for example. All right. Or H, T, H. So each branch here will give you one outcome of this experiment. How many outcomes are there? 8. And we can write all of them here. So H, 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 T, H, T, H, H, T, T. Notice 4 of them starts by H and 4 starts by T. T, H, H, T, H, T, 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 H, and T, T, T. So this is always the outcome, or yeah, the outcome of the first coin. And this is the second coin. And this is the third coin. So these are 8 possibilities. So when we toss a coin 3 times, the number of elements in the sample space, in this case, would be 2 to the power 3, which is 8. If you toss a coin n times, the number of elements in the sample space would be 2 to the power n, because every time you have 2 times 2 times 2. So this is an equiprobable sample space. The probability of each outcome here is 1 over 8. That's why we call it equiprobable. Find the probability of obtaining 0 heads. 0 heads is 3 tails. So he is asking about this event. Let me call it E, not H. T, T, T. So probability of E would be 1 over 8 because we have 1 element and 8 in the sample space. Find the probability of obtaining 2 heads. Well, let me call it F. Now 2 heads means here I have 2 heads. So this outcome is there. Here I have 2 heads. So this outcome is also there. And here I have 2 heads. And that's it. So the probability of obtaining 2 heads is 3 over 8. One ball, and an exercise here. One ball is drawn at random. So how many balls are drawn? One ball. From a bag containing 4 red, 6 white. What is the probability that the ball is white? Probability is how many white balls? 6. In total we have 10. White or red? Well, are there any other balls in the bag? Either it's red or white. So white or red means 10 over 10 or 1 because this is all the sample space. The sample space here consists of either white or red. Red and white. Can the ball be red and white? We don't have this here. Either the ball has red color or white color. So no ball with red and white color. So probability of this event is 0. It's an impossible event. An ordinary die is tossed. When you toss a die, the sample space would be, what is an outcome? Toss a die and notice the number on the upper face. Read how many dots are there, either 1 dot, 2, or up to 6. So this is the sample space. What is the probability of getting a 3 or 4? So he's asking about the event that has 3 and 4. So probability of obtaining 3 or 4 would be the probability of E. I have 2 elements in E, 6 elements in the sample space, and this is an equally likely experiment. Outcomes are equally likely because the probability of each number is just 1 over 6. An urn contains 3 red balls numbered from 1 to 3 to 1 to 3, 4 white balls numbered 4, 5, 6, 7, and 3 black balls 8, 9, 10. So how many balls in general? I have 10 balls in the urn. A ball is drawn. This is very important. We are selecting only one ball. When you select one ball, this ball could have any number from 1 to 10, and it could be red, white, or black. What is the probability that it is red? Well, how many red balls are there? 3 red balls. And the total number is 10. So 3 over 10. Because any ball has the same uh, possibility to be selected. Odd numbered. What are the odd numbered? Let us find. Let us call it E and find the odd numbers. 1, 3, 5, 7, and 9. So he is not interested here in the color. He is interested in the numbers. So probability of E would be how many odd numbers are there? 5. And the total number of poles is 10. Red and odd number. And means it has to be red and at the same time odd numbered. So these are all the odd numbers. Red, the red balls 1, 2, 3. So how many of them are odd? 1 and 3. So only 1 and 3. So the probability is 2 over 10. Red or odd. Okay, or means either red or odd. So I will call it F and let me put all of the red and odd numbers. So the red balls are 1, 2, 3. And let me add the odd numbers. 1 and 3 are there. So I need 5, 7, and 9. So what would be probability of F? How many elements in this set? 2, 4, 6. So it's 6 over 10. Not black. Well, how many black balls are there? 3 black balls. So not black means white or red. And the total of white and red balls is 7. So the probability is 7 over 10. This is the probability of not black. Suppose a fair coin is tossed. A fair coin is tossed 2 times. Okay. 2 times means what? What would be the sample space? We have seen it. HH in this case, HT, TH, and TT. Okay. We did the tree diagram for 3 coins. Now just consider the first 2 branches, these 2. So HH, HT, TH, and TT. And remember 2 coins, so 2 to the power 2 is 4. So we have 4 elements in the sample space. It is equally likely, so probability of any one of them is 1 over 4. Construct an equiprobable sample space. This is an equiprobable sample space because the probability of each outcome is 1 over 4 for the experiment, and determine each of the following probabilities. 0 heads. 0 heads, TT. So this is 1 over 10. What 10? Sorry, 4. 1 head. How many elements with 1 head? 2. So 2 over 4. 2 heads. How many with 2 heads? 1. So the probability is 1 over 4. Now, let us talk about the experiment tossing 2 dice. Okay, pair of dice. Roll pair of dice. And notice the sum of the dots. So what would be the sum of the dots? Well, it could be 1, 1. So the sum is 2. That's the smallest sum. And it could be 6, 6, the largest possibility. 6 plus 6 is 12. So the sums are from 2 to 12. And here are all the possibilities. The first die could be from 1 to 6. The second die from 1 to 6. The first die could be 1. The second could be 1. The first could be 1. The second could be 2. So if we have from 1 to 1, 1 to 1, 6. And from 6, 1 to 6, 6. So we have 36 possibilities. 6 times 6, 36 possibilities. each one of them have the same possibility. So the probability of each one of them is 1 over 36. It is an equiprobable sample space in this case. If he asks me, what is the probability of obtaining the sum 2? Sum 2. So how many elements with sum 2? It's only 1. 1, 1. So the probability of obtaining the sum of 2 is 1 over 36. But the probability of obtaining the sum of 3 is different. It is not 1. So if you look to the sums, the probability, the experiment is not equally likely in this case. So sum of 2, 1 over 36, but sum of 6, how many sum of 6? 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 2, 4, 5. So the probability of obtaining the sum of 6 is 5 over 36. All right. So here, what is the probability of obtaining the sum? The sum is 5. The sum 5. Sum 5, 4, 1. This one. 2, 3, 3, 2, 1, 4. So how many possibilities? 4. So 4 over 36. Sum is 2. There is only one possibility. 1, 1. So 1 over 36. Sum is 8. 8 means this one. 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. So 2, 4, 5. 5 possibilities of obtaining the sum 8. So 5 over 36 is the probability of obtaining the sum 8. A ball will be drawn from a bag containing balls numbered from 1 to 4, 1 to 5. Okay, selecting how many balls? 1 ball. To find the probability that a ball with an even number is drawn, we can use this sample space, this or this. Well, which of these sample spaces is equiprobable? If you select even and odd, what is the probability of obtaining even? We have 2 and 4, two numbers. So probability of even is 2 over 5. Probability of odd is 3 over 5. And in this case, this sample space is not equiprobable. But if you select S2, S2 is an equiprobable because the probability of selecting any number is 1 over 5. What is the probability of drawing a ball that's even numbered? Yeah, we have seen we have 2 balls even over 5, the total number of balls. A coin is tossed and a die is rolled. Okay, so toss a coin. What do you get? Either H or T. Then roll a die. So if the coin is H, the die will give you what? Either 1 or 2 up to 6. And also if the coin is tail, the die could be from 1 to 6. So what is the equiprobable sample space here? The sample space would be H1, H2 up to H6. So the coin is head and the die is from 1 to 6, or T1, T2 up to T6. And we have 12 elements in the sample space. Find the probability of getting a head on the coin and an even number on the die. Okay, what do we have here? Head and even, head and even, head and even. 3 possibilities. So the probability of E is 3 over how many elements in S? 12. Find the probability of getting a tail on the coin. And the number divisible by 3. The numbers are from 1 to 6. Divisible by 3, we have 3 and 6. Only 3 and 6 from 1 to 6 are divisible by 3. So tail on the coin divisible by 3 and 6, I have only 2 elements. So the probability of F would be 2 over 12. this is the end. I will continue the other concept in another uh, video. Thank you very much.